Okay, so I'll be using Desmos.com to create a quantile or QQ plot for this data set that's given to me in myopenmath.com. So we're going to create a quantile plot for the data set below. So we'll go ahead and we'll copy this data set. So I'm just going to go ahead and highlight it. And after I've highlighted, I'm going to right click and copy. And then I'm just going to minimize. So this is Desmos.com. I'm going to open up the graphing calculator. And I'm going to paste my list by first giving it a name. So I'm going to call it capital X. And then I'm typing equals. And then in order to enter a list into Desmos, I'm going to type a square bracket, open up a square bracket. Then I'm going to hit Control and V to paste the list in. Closing the bracket, now I have my list X created, which has 74 entries, 74 elements. So that's my list X. What I want to do is I want to find z-scores for all of these values in my list X. And the formula for z-score says that the z-score of a value is equal to, z is equal to the x value minus the mean, which is the mean of the values, divided by the standard deviation of the values. So in this case, S. So what I'm going to do is I'm going to take the values in this list, I'm going to subtract the mean and divide by the standard deviation of those values. So let's go ahead and get that. All right, so I'm going to type in here that my next list is, I'm going to call it Z, and I'm going to do underscore to make a subscript 0. So Z0, or actually let the subscript be Y. So I'll call this ZY, and it'll be equal to, and then I'm going to open up a parenthesis, actually not a square bracket, a parenthesis. I'm going to take the values of X, so I'm going to do uppercase X. I'm going to subtract from that the mean of those X values. So I'm going to come down here and click the keyboard, go over to the functions on the keyboard and scroll down to the statistics function, mean. So I'm going to click on mean, and I want to find the mean of list X. So I just type in an uppercase X, close both parentheses. Then I'm going to divide, and remember I have to divide by the standard deviation. So I go back to functions, I scroll down to standard deviation, STDEV, and I want the standard deviation of X. So this is the mean minus, or the value minus the mean divided by the standard deviation. Those are going to be the z-scores that come from this list. Now, the next thing I'm going to do is I'm going to create z-scores for a theoretical distribution, basically the z-scores of a perfect standard normal distribution. So to do that, I'm going to first start with a counting variable. I'm going to call it I. I'm going to let I equal all the numbers beginning at 1, then comma, put some ellipses to show that it continues counting, another comma, and I'm going all the way up to 74 since I have 74 elements. So because of the fact that the number of elements is 74, I'm going to let this go all the way up to 74. So that's 1 all the way up to 74. I'm going to close that off. So now I have a list with the numbers from 1 to 74. And what I'm going to do is I'm going to find the quantile for each of those numbers in the list. Actually, before I actually do that, there's one thing that I missed. This list has to actually be in ascending order. So the way this list is now, it starts with 97, then 45, 36, 45. It's not in any specific order, it's just random. So I need the order statistics. I'm going to go back up here and I'm actually going to sort this list by typing SORT, sort, and then opening up a parenthesis. Now, this is a sorted list. Even though it doesn't look like it's sorted here, this list is now sorted from smallest to highest, if you don't do the sorting of the list, the QQ plot will not come out correctly. So now that I have the sorted list and their z-scores, I'm also going to come down here now and I'm going to say the first value in the list, which actually is going to be the smallest value, is going to be bigger than the values to the left of it, which there are going to be no values, but I'm still going to put in a percentage here. So I'm looking for the percentage of the values that the first value in the sorted list is larger than. So that percentage is going to be found this way. I'm going to do capital P, and it's going to be equal to, what I'm going to do is I'm going to create a fraction. I'm going to take the values of I, and I'm going to subtract from them 0.5. That way I'm going to get in between the values. So basically when I is 1, 1 minus 0.5 is half. It's basically the value directly to the left with to the left of 1 with a continuity correction because the normal distribution is continuous. And I'm going to take that and I'm going to divide it by the total 74. So there's 74 total values. What I'm doing is I'm looking at all the values. I'm looking at the in between that value and the value that came before it. And I'm saying that the value I'm looking at is basically bigger than this percentage of the values in the list. So that's what this percentage represents. It represents the percentage of values that the ith entry in this list is greater than. So I'm going to use these percentages and I'm going to create a theoretical normal distribution, standard normal distribution of z values. And here's how I'm going to do that. So I'm going to say this is actually z subscript x, zx, and it's going to be equal to, and I'm going to start with a normal distribution, just normal dist is the normal distribution, and I'm going to just open and close a parenthesis, which gives me the standard normal distribution. As you can see, it's graphed over here. This is the standard bell curve, standard normal distribution. But then I'm going to hit a period. I'm going to type a period, dot, and I'm going to type inverse, inverse, and then CDF. And when you type inverse CDF, the values that you want to put in, you're going to open a parenthesis. The values are those 75 percentages. This is going to create a list of 74. I said 75, I meant 74 percentages. This is going to create a list of 74 z-scores from a standard normal distribution. What we're going to do is we're going to create ordered pairs with the sorted list of z-scores up here and these theoretical z-scores, and if our actual data comes from a normally distributed population, we should expect these ordered pairs to fall somewhere along the straight line y equal x randomly with no real pattern per se. It's just going to be randomly scattered about this graph. So let's go ahead and put those ordered pairs in. The x values on the ordered pair are going to be the x values that come from this theoretical normal distribution zx. So I'm going to make an ordered pair where the first components are z underscore x, so z subscript x, and then the other coordinate, the y coordinate, is going to be z underscore y, which are the y values that come from the, are the z-scores that come directly from the sorted data list. So here's my QQ plot. This is actually the QQ plot. When I take a look at this QQ plot, what I'm expecting, if it's a normally distributed population that these values came from, is for there to be randomly just values along the straight line here. But what I see here is a distinct pattern, kind of a crest and trough pattern here. So wavy pattern. So this is definitely not a normally distributed population that this data set came from because of this distinct pattern that we see here for the quantile plot.